This is Unit 4, Review 2, numbers 4 through 7. All right, so number 4, 5, 6, and 7, it says, does the mean value theorem apply? So basically when you do that, you're looking to see if there's any discontinuities in each one of these. If I just quickly look at that, number 4, it's polynomial, there's no discontinuities. Number 5, there is a vertical asymptote here at x minus 2, gives you the x is equal to 2, a vertical asymptote. The question is 2 in my region? It is, which means this is not continuous. Which means you cannot do the mean value theorem. It does not apply here. So it's not continuous because you have a VA at x is equal to 2. So we don't have to do anything else with that problem. It's actually a really easy problem. All right, number 6 is a polynomial, so again, that will work. Number 7 is also a polynomial, so that one will work. So if I look at number 4 here, I'm given my equation. All right, when you're doing this, you want to set the derivative equal to the slope of the secant line. So my derivative here, which is going to be my f prime of x, is going to be 3x squared minus 4x minus 3. I want to set that equal to my slope. So I have to find out what the slope is over here. So when I go through and try to do that, I'm going to be looking at taking this 1 and my 3 and plugging it into the original. Again, if you want your slope is y minus y over x minus x. So I take my 1, I plug it into the original, and I end up with 1. Take the 3, plug it into the original, and I end up with 5. So now I find my slope from those two. So when I do that, that's going to be, do my work up over here, that's going to be 5 minus 1 over 3 minus 1. So that's going to give you a 4 over 2, or just 2. So I'm going to set my derivative equal to my slope. All right, so now I need to solve that. The easiest thing to do is to plug this into y1, plug this into y2, and solve those. Sometimes you can factor it when they're a little bit easier. This one's a little more difficult. Okay, so you could technically bring the 2 over, set it equal to 0, and solve using the quadratic formula. That will work if you do not have a graphing calculator. But the easiest thing is to find the intersection point between this one and y1 and this one and y2. And when you do that, you should find 2 intersection points, but only one of those is going to be between 1 and 3, and that's at x equals 2.12. Remember, if it is continuous between 1 and 3, which we know it is, there has to be an answer there. All right, and clearly there was an answer for this one. All right, number 6, we're going to do the same exact thing here. First, I'm going to take my derivative, so f prime of x is going to equal to 3 times 1/3 is just 1, so it's really just x squared, and then minus 3. Again, I'm going to set that equal to my slope. What slope am I talking about? My x value, my start, negative 2.5, my another x value, 3.5, the end value. Take those two, plug them into the original. When you plug in negative 2.5, you're going to end up with 2.292. You take 3.5 and plug it in, you get 3.792. Make sure you do go and practice that. I'll just take my word for it, make sure you can get those. Now again, I'm going to find my slope. When I do that, that's going to be 3.792 minus 2.292. That's all over the 3.5 minus a negative 2.5, so it really becomes plus 2.5. That comes out to be 1.5 over 6, which when you reduce it is just 0.25, so it's 1/4. So again, x squared minus 3 is equal to 0.25. All right, again, when you do this, you could add your 3 and make it 3.25, and that's probably the easiest thing to do here. X squared is equal to 3.25. Again, add the 3 to the right side, and then you can just take the square root, and you're going to get x is equal to a positive and a negative 1.803. And the other way you can solve it is just like we did number 4. You can take this, put it into y1, take this one, put it into y2, find the intersection points. All right, but this is actually faster. All right, this problem, the algebraic method is the quicker method to do. So now I need to decide, are both of those in my region? And they are, so therefore they are both my answers. All right, so that happens twice. Last one here, number 7. Again, I'm going to take my derivative, so f prime of x here is going to equal to 4x to the third minus 9x squared minus 2x. Again, I want to set that equal to my slope. The slope of the line, when I take my negative 3, plug it in, I'm going to end up with negative 4. Take your 1, again, plug it into the original, you're going to get 8. Find your slope here. This is going to be 8 minus a negative 4 all over 1 minus a negative 3. That's going to give you a 12/4, which obviously reduces down to be a 3. So again, go through and solve this. All right, derivative is equal to my slope, which is a 3. Easiest thing for this one probably is to take this and you actually could factor this. If you brought this 3 over, you would factor by grouping, actually. All right, but you could also take this and put this into y1, put this into y2. Either one is acceptable. When you then ultimately go through and solve this, you're going to have x is equal to negative 2.326, negative 0.531, and 0.607. So it intersected, these two intersected 3 different times. And all 3 of those intersections are in my region. So I need all 3 of those to be my answers.